Live. You're live.
Is it going?
Yes.
There it is. That's funny.
What?
Hey guys. Hopefully you guys can hear me. Let me know if you can hear me okay. I've got a little bit of a stuffy nose tonight, so I apologize for that. Are you saying good night because you're saying goodbye, or are you saying it's a good night, PQ? So, guys, one of my questions, when I put out that I'm doing a live stream, I only did this one like an hour and a half prior, an hour prior to my live stream. But when I say that I'm going to do one, and I put that little thing out, did it give you an email saying there was going to be a live stream at 8:30, or was there some sort of notification? Can you tell me and let me know what that told you? Because I would be curious to see if it told you that I was going to do the live stream. I'm brand new to this, so I'm just asking for help in figuring it out. Because maybe what I'll do is put a scheduled event in days ahead of time so that you guys can prepare for it. You know, maybe 4 days ahead or 2 days ahead. And I'm just trying to figure that out. So did it send you some kind of a notification? I'm a little bit curious. Just let me know. Okay. So wanted to do a little question and answer session tonight. I'm going to try and keep this one to just 30 minutes, but we have some really cool stuff to show. I'm going to have my helper here. My wife is going to walk around with me, and hopefully the video won't be too shaky or anything, but I'm going to show you where we're at with the scoops that I have already attached. I've got 3 of them on, and I have over on the other side there 2 more scoop pairs almost completely glued up and ready. So I'm going to show you a little bit of that and then give you a little intro to what I'm going to be doing after the furling mechanism is all built. The next part, of course, is going to be getting the cart built. The cart's going to allow me to hold the generator. It's just an off-the-shelf generator. I showed that probably 4 months ago in another video. It's going to allow me to hold that generator in there. I'll have like a 4-to-1 or a 5-to-1 ratio between the turbine scoops and the generator, and that'll give us the RPMs that we need at the generator. Okay, thank you, Radio Tac. So you did get a notification via YouTube. That's cool. So I'll put it out maybe 2 days ahead of time or something like that next time I'm going to do a live stream. And then thank you, PQ. And then that'll give you guys a heads up when I'm actually going to be doing a video. So cool. From Peru. I like it. At this point, I'm going to go over. I'll have my wife. She'll try and do things that won't shake too much. Just go ahead and unplug it there.
Sorry.
Sorry for the shakiness, but we're going to go over and show you what we've got going on over here. So come with me. So in here, I have the last 2 pieces of acrylic that I had were horrible. I wasted 8 of them trying to get them to melt properly, and I fought and fought with them. So I'm just brute forcing it. You can see a little bit the edges are bowed out here and here because it did not want to cooperate. So I couldn't get a good the very last 2 scoops, I couldn't get the proper little 12-inch piece of acrylic to behave. So this guy's in here, he's been gluing up, and this is my second to last one, and then the last one over here, it's also screwed up. You can see it's got a weird, not kinked, but it's not very good. I'm just going to deal with it because I'm tired of delays. This part's really not critical, and in the next version, I'm even thinking of eliminating this completely. So those are my last two kind of messed up ones over here. These guys are good to go. The gears and everything are glued in. So this is my fourth scoop pair. The other three scoop pairs are already on. These guys are already installed on the furling mechanism. We have the 1-inch cold rolled steel. That's going to be the main driving shaft for the turbines. This is going to allow us to transfer the torque from the turbine scoops into the generator, well, into the pulley that would then drive the generator. So once these two, I have to just check a few more joints, glue them up, probably if I get some time, tomorrow's Easter, but I'll probably get these finalized, install them, and then these last two horrendous ones because of the the problems there. That'll be 5. These two will be the 4th, and then I need to pull the furling tube down a little bit, and then the 5th one will be on. So we'll have all 5 of the scoop pairs in here, and the complete 180-degree axes of rotation, because each of these scoop pairs is 36 degrees offset from the one below it, which as you move up, 36 times 5 gives you 180. So the helix, basically, as it's rotating, the helix will be much more visual when you see it rotating with all 5. So once this is complete, I will have we can go back over here. Once that's complete, I will have one more piece that needs to be added to that, and that's going to be a worm gear mechanism. And then the worm gear is going to tie into a standard spur gear. And that worm gear spur gear combination, do you need my help or you got it?
I got it.
That worm gear spur gear combination will allow us to basically have full control over the furling mechanism as we furl and unfurl. As soon as you stop putting any power to the sorry for the shaking there, guys. As soon as you stop putting any power to the furling motor, it'll hold the scoops at whatever degree they were furled. So I was walking around, I didn't get to look at the questions, but I'll go. Okay, get a piece of pipe that diameter from. Yeah, Doug, it is kind of what we did. We actually baked those pieces of acrylic in the oven, and we do have the molds. If you look in my other videos, I don't know if you must not have looked at some of the older videos, but I definitely show that. I've got pictures of it. They're both on Facebook channel and everything. But I do have a large, it almost looks like a turtle shell. It's the half circle that I bake the large pieces of acrylic on, and they come out beautifully. The large ones, I don't have any problem with them at all. It's those little small ones. And I think what happened was my first batch of 8 that I got, originally I thought I was going to only have 8 turbine scoops instead of 10. Those came, and I believe when they cut them if there is a striation or a I don't know, I guess it would be like the crystalline structure is almost like grain of wood. And it seems that they cut the 13-inch along the grain with the first batch, but the second batch they cut it cross grain. And so that's why I think I'm getting all the horrible, maybe, hun, you could go over and grab some of them and I'll show them.
Oh.
Some of the crappy ones. I literally ruined 8 of those small ones trying to get just 2 good ones. I just needed 2 good ones and I couldn't get them. So, hey Mark, how are you? If the scoops are closed, where is the power coming from to open them up?
Here, babe.
So Chris, I'll answer that in 1 second. Here's some of the messed up ones. I mean, these things are horrendous. You can see they're just all cattywampus, and it's like they didn't want to melt or behave correctly. They're curled up on the ends. I know I'm moving it around pretty quickly here. I apologize, but they're awful. They're absolutely horrendous. So I have 8. of these that are just a freaking mess. They're not even, I mean, when you line them up to each other, they're fatter in the middle, skinnier on the end. It's so screwed up. It was horrible. They're trash. So Chris, your question. The scoops are never, ever going to be closed. The scoops are always going to be opened, and normally they're going to be opened 100%. Now, when we start doing testing, if I determine that 100% being open as far as they can be, that's what I'm calling 100% right now. So being open as far as they can be might not be the most efficient. We might find that in 10-mile-an-hour winds, it's best to have them opened only 90%. And in 15 miles an hour wind, maybe it's best to only have them open 87%. That's the fun part about gathering the data. We're going to do all kinds of various wind speed testing and get those algorithms and map it out. But once we have that mapped out, then you would plot things into your Raspberry Pi and into the little controller so that it always has things opened up to what is the most optimal for the wind speed. And in default, when there's no wind at all, it's just going to be sitting there with them opened at the, 80, 90, 100%, whatever it was that the wind speed that it was moving at when it was really spinning in the last hour or so before the wind died down, it would be opened at that ratio still. So once the wind starts picking up again, of course it's going to begin moving. So the only point where you would start closing up to the point where it's almost fully closed would be when you're in a hurricane force wind. And at that point, yeah, Harmony would be closed up so much that you'd still be getting your maximum RPMs. It would still be going around at maximum RPMs, but it might be closed up, 80% closed at that point rather than 80% opened. So what about closing all the way because of hurricane speeds? Again, if you close all the way, it would have to stop because there'd be no way it could drive it anymore. I think that would actually be more dangerous for the main, the driving shaft or the drive shaft, the torque shaft, whatever you want to call it. The main turbine shaft would then be subjected to winds from that one direction only, and it would be getting pushed and pushed and pushed in that one direction. If you would allow it to keep spinning, even if it's only opened a tiny, tiny fraction, it's still going to be spinning. Now you're dispersing that load, and instead of pushing on the pole in one direction only to weaken it, it's going to be spinning so that the pushing that happens on the pole is going to be more uniform. And I think that would be safer for Harmony to actually stay opened, even just a tiny bit, and be spinning right through that hurricane rather than closed completely. Does that make any sense? Okay, how about what amount of air can it use? Okay, so PQ, I haven't yet figured out what the maximums are. Obviously, this acrylic prototype isn't going to be nearly as strong as the injection mold plastic that we're going to do later on when we're in true production. Phase 1 is going to be just the prototype improving the performance. So we're getting 800 watts of power in a 15 mile an hour wind. We're getting 900 watts of power in a 12 mile an hour wind. Whatever those ratios are, whatever those numbers are, we're going to publish them. We're going to release that information, and then I'm going to be going to investors with that information. Hopefully it's good, and looking to go to phase 2. Phase 2 is going to be where we go into very small production, probably 6 units, maybe 10 units max, where we make just enough of these to get them out to our beta customers, the customers who have been waiting a long time for these. And there are places like the Masonic Village who wanted these over a year ago. Get them out there, get them set up, get them running. They're going to be out there full time and exposed to the wind, exposed to the conditions, and gathering data for us. That'll help us to get a larger base model of how the algorithms are doing, how the wind capture is going, and how they perform in real world conditions. I don't really see more than 6 to 10 units being produced in that little beta phase or phase 2, where we've gone from the single prototype to now having a limited rollout just to get better numbers. It'll also give us time to kind of form the company, get a few people hired, get a very small skeleton crew so that we can produce these things and start looking at, all right, now phase 3, after we've done a few months of that testing, the data comes back, we now go into kind of a full production mode. And of course, that's going to ramp up as well. That, that's going to be, we grow organically. We're going to start slow, we're going to start local, and we're going to have installers, we're going to have the engineers, we're going to have CNC machines, injection molding, and we're going to be putting these together, making them and installing them on people's premises right there for their residents. Yeah, there's going to be legislation and borough townships to deal with and things like that, but we'll deal with all that stuff. We're changing the whole paradigm with this. We're looking at producing Harmony for somewhere in the $8,000 range and giving you a 5 to 7 year payback on it. And if we can do better on those numbers, that'd be great, but I have to have some kind of a starting point, so that's what we're thinking. Right now, you can't buy a wind turbine for, anything even close to that. There's some crappy ones out there that'll produce, they're touting that, they'll produce 1,200 watts in a 25 mile an hour wind. Great, but they don't get anywhere near that below the 25 miles an hour, and they don't get anywhere near that production above the 25 mile per hour wind. They have a very sharp peak, and then they come right back down, and they only produce that promised output in that very narrow little window at the top of their peak. Harmony, when it goes up to the desired wind speed to get maximum production, should then level off and continue producing as it moves, higher and higher and higher wind speeds, because Harmony will just furl down as it's spinning. It doesn't have to dump load. It doesn't have to do anything like the other ones do. So let me see here. The generator will be able to run at very high speeds. Chris, the generator initially that we're doing with the very first prototype, phase 1 here, it's just an off-the-shelf 1,000-watt generator. I showed that in other videos. It's just going to be, I think it needs somewhere around 400 RPM to get up to the desired output. So that's no big deal. Okay. Yes, Radiotac, we do want to produce smaller units, like RV and boat size units. So absolutely, recreational vehicles is in my target range, but that's going to be after phase 3, after we're in full production. We've got some residential units out. We've got some money coming in. We're, starting to actually move with the company. Then absolutely, I want to build you guys units that work for your RVs, your boats. We want to get them onto the residential. I don't give a crap about putting these things on the grid. I don't give a crap about competing with the 6 megawatt turbines out there. And that's what everyone's like, oh, the efficiency sucks on vertical axis wind turbines. Yeah, well, when you're talking industrial scale, sure, but not at the residential level. At residential level, what matters to people is their payback on investment. How much money they're saving on their electric bill every month, and then does that translate over a few years to the unit paying itself off? If the answers there are yes, who gives a crap if it's a little less efficient than a horizontal axis wind turbine? What you care about is getting results for you and your household that save you money, and at the same time are reducing, my hope would be to reduce plastics globally, because we're actually using scrap plastics and, plastics that are coming up on the beach with the Precious Plastics initiative out there. I'd love to couple with them to be getting plastic from all over the world, injection molding it into the Harmony turbine scoops, and then we're also producing green energy because it's gathering it from the wind, and you can take that into a grid tie inverter, or you can put it into a battery bank for your house. It doesn't really matter what you do with that power. Even if you're just grid tying it and it's making your meter spin slower, you're still reducing the amount of grid power that you're demanding on a monthly basis. And you put 2 or 3 of these on your house, you're probably going to be getting a paycheck from PP&L, from MedEd Electric at the end of the month, because one's not going to be enough to offset your electric bill completely, but 2 or 3 might definitely be able to. We, in my house, we use like 900 kilowatt hours a month. I think the average in Pennsylvania is somewhere around that. And if Harmony is able to produce even 800 or 700 watts an hour in a 10 mile an hour wind, the calculations that I'm doing show that we should be able to offset a third of your electric bill with just 1 unit. So it's pretty cool when you think about it like that. All right, we've been running now for, what time is it? My clock is wrong, 20 minutes. So I don't want to make this one really long. If there's any other questions, we've got 12 people. There was 13 on a little bit ago, so that's pretty cool. Are there any other questions at this point? Anything you guys want to know? I'm just days away here from getting scoops number 4 and 5 put onto the furling tube, and then finally I can glue everything into place on the furling tube, and then I need to put the worm gear and the spur gear on the bottom to control the furling. But I'm going to start working on the cart after this to allow me to convert the power from the turbine scoops into the generator. So that's going to be pretty exciting. So Chris, it seems there would be... It seems that there would be a wind speed on the high end that would burn up the motor. So, Chris, if I would have it at a static, like, it's just open the whole way, as it's spinning, yes, it would spin faster, 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 and that would burn up the generator. But by it starting to furl, by it closing down, then what you're doing is reducing the RPMs that Harmony is going to be generating in that same 30 mile an hour or 40 mile an hour or 50 mile an hour wind. So let's say Harmony reaches its maximum RPMs at a 20 mile an hour wind. So in a 20 mile an hour wind, for instance, I'm not saying this is the case, let's say it hits maximum RPM and we set that to be, I don't know, 400 RPM. We don't want it to spin any faster than 400 RPM. So once it hits that, it's going to be running an algorithm constantly saying, am I above my safe RPM limit? If yes, then it's going to start furling down and closing down. And then it, again, in 10 seconds, am I above my safe RPM limit? If yes, furl down. So it's going to dynamically adjust its furling to close down and slow itself down so it can still produce that 400 RPM desired output. But yeah, I don't know, 150 mile per hour, we better have this thing like reinforced with carbon fiber at that point. Who knows? It really, the science behind it is being able to furl is what's going to allow it to continue producing at full power in those high winds. Then how high of wind it can sustain is going to be a matter of the materials actually in Harmony. Now, we don't want this thing to cost $20,000, so we're not going to put carbon fiber into it. We're going to do injection mold plastic, and it's going to be really tough stuff like your waste management trash can. Those things get blown over and knocked over and dinged around all the time, and they're fine. Harmony doesn't have to be indestructible, because even if all 5 levels of your blade scoops get wiped out by some tree coming down on it, your generator is more than likely going to survive without a scratch, because that's a very carefully protected and secure unit on the ground, bolted to a concrete pad or up, in the roof, in the peak of your house, inside your attic, and protected. It's only the turbine scoops that would be vulnerable to something hitting or falling on them. And if they break, they're going to be a very, very minor expense to replace compared to the rest of the unit. That's why Harmony is such a cool unit. You don't have to climb up 100 feet in the air to do something to it, to fix it, to maintain it. It's right there on the ground. And if all of your scoops got destroyed, it would probably only cost like not even $1,000, I'm guessing, to get them all replaced. That's how we're looking to do this, so that you guys are back up and running with a minor inconvenience of, having the new parts shipped to you, and then you can get back up and running. Radio Tech, I'm not sure what kind of noise it will produce yet, because obviously I haven't run the full-scale model in winds at all yet. When I was running my little one and I actually, stuck it out the roof of the car as I was going, it makes a whirring noise, but that little one was designed a little bit differently, and it had more crap in between each blade pair than the big one does. The big one is 36-degree offset, so it's a lot smaller angle between them, and there's no junk in between each of the scoop pairs. They're almost sandwiched right on top of each other. So I don't want to speculate how much noise it's going to produce until we really hear the full-size one running. Yes, I will sell worldwide I don't even know how to say your name, EIB. Yes, you're in Denmark. Yeah, I'm thinking it's going to produce 12, 24, or 48 volts, whatever you guys want it to. You know, you would set the generator to your desired needs. But my goal would be to have it produce DC directly that you can dump right into a power wall or a battery bank and go off grid with it if you want to. Then it will, okay. So Chris, you're saying then won't it close eventually in high wind speeds? It will close, but it should never ever get to a point where it closes 100%. It might be closed 90% or 95%, and it's only opened a little sliver, but you know, you're in 100-mile-an-hour wind and the thing is still spinning at 400 RPM. There's a point where, you know, when you close that extra 1% or whatever, it's going to start slowing it down. I don't foresee a point where you would ever have to have Harmony closed up 100%.
How does it open back up? That's
So he's okay. So if it would be closed 100%, you know, there shouldn't be a case where you ever hit 100% closed unless you're in maintenance mode and someone is working on it. And in that case, then it's just a simple command to the computer that's controlling it. We'll have probably a small onboard DC power supply. You know, the little stepper motor, a NEMA 17 motor to control it, only takes a few watts of power to open. It's not going to be a fast opening. It'll open very slowly, but it won't be a big deal to open it back up if it needs to be. You'll be able to get it as the homeowner open back up with a simple touch of a button, as long as that DC power supply that's down in the generator and protected has been operating correctly. It will always be topped off because it'll only need to be charged up, you know, by power once a week, and you're certainly going to be producing power even in low wind places in the United States way more than once a week. So the DC power supply should always be topped off as long as it's not a faulty mechanism, and it would be nothing more than a simple touch of the button, or we might even program it in that the if it's not in maintenance mode and it's not spinning, its default action would be to unfurl, always unfurl, if it has power to do so. So the DC power supply would enable it to do that. Can we go back to the first question? If you closes up right. Okay, so Mark, I think I did just address that. That, you know, a small onboard DC supply will be in down in the generator, small battery, you know, lithium pack or something like that. It doesn't have to be anything high tech, just a small DC power supply to allow the unit to unfurl in the event that it did somehow furl up completely. It's nothing more than a couple watts for that little NEMA 17 motor to slowly unfurl. It might take, you know, 90 seconds or 120 seconds for it to slowly unfurl all the way to open again, but that's fine. You know, it's not going to take a lot of power for it to do it. That's the beauty of the worm gear to spur gear relation. Okay, so I think all those questions there were basically about it closing up in high winds. How will it reopen? And yeah, that's just going to be a logic algorithm for it to check that, or a manual override, push the button, you could reopen it in case something goofy happened. Yeah, so somehow healthy. Oh, that's you, hon.
That's me.
Yeah, the logic that is used to close the scoops is also going to be running a reverse algorithm that checks, just like your toilet. Your toilet fills up to a certain level and then the water shuts off and it stops. Otherwise it would just overflow all over the place. When your toilet flushes, if you don't flush a lot, like if you just start to push the thing and it flushes a little bit and then you let off, it doesn't immediately fill back up to that top level. It has a lower limit that it won't start filling until it hits that lower limit. Or your air compressor comes on and it fills up to that upper limit, and then as you're using air out of your compressor, when it hits the lower limit, then your air compressor comes back on. Same thing with this algorithm. It's going to be asking, am I above my safe RPM limit? If yes, furl, 5% or furl down 3%, and it'll keep running that loop. But after it asks that question and it doesn't get a yes, then it will say, am I below my desired RPM limit? And if the answer there is yes, then it would do the opposite and it would begin to unfurl to open back up. So it's always going to ask the question, the more dangerous question, am I above my safe RPM limit? And if yes, it'll furl, then it'll loop and it'll ask it again. And if yes, it'll keep furling until it gets a no there. When it hits a no, that means it's furled down enough, and now you're in a position where it's at its safe RPM limit, and now it's going to start asking, am I below my safe or my desired RPM limit? And if the answer there is yes, then it's going to begin to unfurl. So it'll be like your air compressor. It'll be operating between its maximum safe RPM limit and its lowest desired RPM limit, and it'll be furling and unfurling dynamically in between those. I hope that were good explanations. Thank you, Radio Attack. I'm sorry if I got a little tongue twisted there, but yeah, there are two algorithms that are running in a loop, and that's how it's going to be doing the furling and unfurling. Yeah, Chris, that's what the onboard battery. So you were saying it seems like there would need to be a backup battery on. Absolutely. And that's why I want to use a little Raspberry Pi unit or something like that, because those little guys, they run off of 5 volts DC. So when you're sitting there and there's no wind for a whole 2 days, you know, you just, all we have to do is size that little DC battery pack big enough that it'll be able to have enough to fully unfurl or furl a few times, and at the same time have enough reserve to run that Raspberry Pi for several days. You know, we'll probably shoot for a week of being able to run the Raspberry Pi unit before it gets into, you know, problem. And, you know, at that point, there's other ways around it too. You are going to be tied into a grid system, so you could, you know, there'd be things where you could get crazy and feed power back if need be to charge your DC power supply, but it's unlikely that you would be without wind for such a long period that you wouldn't recharge that DC power supply. You know, even a small 12-volt gel cell battery, I know that's not even lithium, but that would probably, a 12 amp hour or even an 8 amp hour, one of the gel cells, the little bricks that they have, would probably be sufficient to keep that Raspberry Pi running for a week if it's not doing anything other than monitoring air, you know, airspeed and stuff like that. Those are just engineering questions at this point. How big we make the DC power supply, it's all academic. We just have to, you know, figure out what seems to be a good combination price point of, you know, you could, sky's the limit. You could spend $1,000 on putting a DC power supply in there, but do you need that? Probably not. So as long as we have good solutions for the odd situation that may happen 1 in 1,000 times, then we should be fine for the most part. Okay, so any further questions at this point? We had some really good dialogue going there. Thank you for all the questions. Yeah, there we go. A solar cell. I think absolutely every wind installation should have its brother sitting there right beside it. The two should be symbiotic. Wind and solar both feeding into the same source. Because when it's dark and cloudy outside and you don't have any sun, you've often got a lot of wind. But when it's bright and sunny, usually you don't have wind, you've got the sun. So the two should be together. It should never be a question of, well, you know, Chris, how are you going to compete with the solar industry out there? I don't want to compete with them. I want to work with them. The two should be together. When thin film solar comes out, I'm going to have it on my roof, and then I'm going to have Harmony sitting on this corner of the roof and the other corner of the roof. So there will be 2 Harmony turbines up on my roof and solar cells all in the middle. You know, simple. And yeah, if you're doing something cool like that, then absolutely that could recharge or always be used to top off the DC power supply if there is no wind. So, you know, there's a lot of really cool creative ways we can do things. And especially if you're dumping into a power wall of some kind, you could always have an emergency system that if your DC power supply is getting dangerously low, it could open up a relay and recharge that DC power supply for you or something like that from your power wall. There's all kinds of cool ways we could do it. Yeah, Radio Attack, you're absolutely right. A small solar cell could easily do it. So centrifugal advance regulator. Are you talking in the generator, or are you talking in the turbines blades for furling? I'm not sure where you're coming from with that question, PQ. Mark, thank you for translating his question. Chris, you said you have a lot more to discuss to the seems like you're not seeing some things. Chris, can you elaborate? That question's a little bit unclear how you asked it. And PQ, I would need to know what your question about centrifugal advance regulator would be in regard to. I'm thinking, on the turbine scoops for controlling RPM or something is what I'm thinking you're getting at, but I believe a simple algorithm tracking RPM would be all that's necessary. Again, I'm trying to keep costs down, keep it simple, keep it very, very straightforward so the engineering is easy, the algorithms are easy, the Raspberry Pi is easy, everything is easy to be deployed, everything is inexpensive for the homeowner, and you get your money back in a short amount of time. So, Chris, you're saying you don't think that I'm planning for the fully closed situation and high speed winds. No, I don't ever plan on Harmony being fully closed. I keep saying that. I would think it is more dangerous for Harmony to be closed completely in high winds, where if it says I have furled down 99% and I'm only opened 1% and I'm still above my safe RPM limit, then at that point I would say it's got no choice, but it's going to have to keep spinning, because it would be more dangerous, I believe, to close that last 1%. And now Harmony is going to be sitting there getting buffeted all from one side, that you're going to probably break the turbine scoops at that point. It'd be safer to risk staying open that 1% and continue spinning. I believe that would be safer for it to do than shut down. The generator will have to be taken into account, that we would allow, I don't know, those are engineering questions that are really, you're talking super high winds before you get into those ranges. I don't know, at that point, you could even build things into it like the coupler, where you lock the turbine blades down into the generator, could be set for a certain amount of pressure that it would just snap off or break, at which point you're going to lose your turbine blades, but you're protecting your generator from over revving. So there's a lot of things to be done there, but I don't think we need to answer all of those questions right now, Chris. Those are things that those things can be worked on down the road. So it's kind of something that can be done. We'll be doing a lot of that testing and the destruction testing later on down the road. We'll take it to wind tunnels, Penn State's wind tunnel. There's other Ohio State and other places where we'll be putting it in there, and we'll be running this bugger at 150, 200 mile an hour. I don't know, whatever the turbines can take, we'll be pushing it to the limits, and we'll be destroying them just to see how well they hold up in super high winds. Yes, I agree that the motor could burn up in those situations. So we're going to have to work on what those scenarios would be and how to get around it. Like I said, it could be something as simple as, after a certain point, the pressure is so great that you build a mechanism in it that it would snap off, so that your turbine blades snap off and go hit the tree line or whatever, hit your neighbor's house, I guess, at that point. But if the winds are that high that it's causing that anyway, you're in a hurricane situation. So there's going to be destruction going on all around you, trees coming down, God knows what. So you're just saying that in certain places you need to have the high speed wind safeties in place. I get that. And I'm not saying we're not going to have them. I'm just saying it's too early for me to elaborate on what those safeties are going to be before I even have funding, even have the team that is dedicated to doing the high wind destruction testing and safety and operations in that end of things. So that's a little bit further down the road than I'm prepared to talk to at this point. I hope that doesn't make you angry. It's just, I'm going to be honest with you all the time. I'm not going to sit here and make crap up just to sound good. It's a problem that we are going to deal with, but it's down the road. Yeah, Sleeping Dog, if the wind is blowing 200 miles per hour, you've got a lot bigger problems than your VAWT. You're absolutely right. And that's kind of where I'm coming from, you know. So PQ, you're asking about this centrifugal advanced regulator. Mechanical in this type of work is to be done because the air forces the blades to be open, but to a certain revolution. PQ, it's not going to be a centrifugal unit that's opening and closing the blades. It's not going to be based off of a ball governor or anything like that, or a centrifugal unit. It's going to be an algorithm, a worm gear and a spur gear controlling the furling and unfurling of those turbine blades. Yeah, Chris, if it closes up and it has the supports, it would be fine. I agree, and especially the backup battery for it to be able to unfurl. I don't think it's going to be a problem there. You know, I think this is stuff that's going to be addressed in the future at an appropriate time when we have the appropriate team and funding to look at those scenarios, and especially in places like Puerto Rico where we need to have those regulations. We're going to do it. We're going to do the work for you. Our company is not going to be about maximizing our profits and putting out a crappy product just so that we can make more money. Our goal, our entire goal for existence, creating more, is going to be about creating more opportunities, creating more solutions, creating more innovations. It's going to be about doing all kinds of things to help society, to help our world be a better place. That does not mean making me and my company rich. That would be the furthest thing from my goals. So I'm going to be taking the money that we're making and putting it into making better products for you. That's where we're going to be, hopefully, different from all the other competitors out there who are just trying to maximize profit based on some goofy little statistic that their wind turbine produces this amazing amount of wattage in this, you know, little tiny band of 22-mile-an-hour winds, but anything above and below it, you're screwed. So I'm not making a product like that. I'm making a product that's going to hopefully make a lot of sense. And when you drive down the road, you're going to see a Harmony vertical axis wind turbine on every roof or every other roof. That would be my goal, where we're helping our world, we're helping communities, villages, counties, and communities to reduce the impact on the grid, to get rid of the need for the huge infrastructure that we have in the grid, because we have solar and wind working symbiotically together to make our world a better place. And it starts at the residential level. All these big companies trying to put these massive turbines out there for big grid power, it's all about building onto an entire ancient architecture that was conceived of, 150 years ago, and that structure needs to be thrown up, crinkled in a ball, and thrown away because it's so screwed up, it's so band-aided together, it's all strung up so goofy that there's no point in even having it the way it is right now. But we're stuck with it. The power lines going all over and spidering back and forth and spaghetti stringing all over because there's really no choice right now. I'm looking to give us a choice. I'm looking to allow us to actually invalidate and make all of that moot. Let's get it to the point where we're producing residential wind power and solar power for our communities and our local houses on a level where we don't even need the grid to be even 1/100th of what it is right now. All right. Well, I think I've talked long enough. My wife is probably looking forward to me cutting this off, and my throat's beginning to get a little dry. So what's up today? Edwin, your sentence is a little bit choppy there. It's a little hard to read. Oh, thank you, Mark. Oh man, yeah. Get to bed, Mark. 2:15 in the UK. I'll have to do these earlier so you can tune in and you don't have to be up so late. Sleeping Dog, I'm looking to actually have this. My patent, well, it's a provisional patent that I have right now, is on the turbine scoops and the generator. And the generator that I'm looking to do, I want to have it direct coupled. We'll see if that's possible. But I'd love to make it direct coupled. To do that, I'm going to have a pretty wide diameter for the rotating plates to get the speed passing by the magnets high enough that you can do direct coupling. But I would love to do it without any gears at all, because the expense there would just be in figuring out what kind of a material we can do to make our plates large enough and sturdy enough that they can handle a 4-foot diameter circumference or something like that. But I don't think we have to get too crazy with the generator size to do direct couple. It just needs to have a pretty large circumference to get that tip speed up to where we need it to be. I'll worry about the generator down the road after we get the funding and get things going. Initially, we'll just use off-the-shelf generators in the round 2, okay? The round 2 being a couple beta sites. While we're in round 2 testing, we are going to be working feverishly on getting the generator perfected for low volume commercial rollout. Edwin, I'm not going to go back through a whole explanation, but I'm almost done putting all 5 scoop pairs on and the furling tube together. I have the worm gear and the spur gear to add to the bottom to control the furling and unfurling, but the next steps are going to be, after I finalize that, it's going to be putting the generator box together, the cart, whatever you want to call it, to allow me to gather the power data from the turbine scoops, so that I can then take this to the investors and, go for round 2 funding. Okay. Chris, I want to stay the inventor. I don't want to be running a company here. I want to do the R&D. I want to be making the inventions that make our world a better place. So I don't want to run the company. I'm looking for people to help me run the company. People who want to run a company for a living. If you want to be that person, please, by all means, contact me, let me know. Here's my email address, guys. Email me if you want to send me something private. Yeah, CEO is an open position right now. I've got a few people that I've talked to about it, but I'm not looking to run the company. That's not even the most remote thing in my mind. I want to be in the R&D department working on the tech to make the world a better place. Yeah, thank you, Chris. I agree. All right. Oh, you're welcome, Edwin. Thank you, guys. I'm going to sign off now. Thank you for all the people who logged in and asked questions, and I'll try and get another video out next week, and I'll do a better job of getting a notification out probably 2 days prior to when I do a live stream for you, so that you can actually plan on it. And maybe, for Mark's sake, I'll even do it at like 5 p.m. next Saturday or something crazy. All right, guys, take care. Thank you.